The last thing we're going to take a look at is creating summative assessments and the difference between creating a summative assessment and a formative, and really just boils down to purpose. Okay, that the what is my purpose in doing this? Is this really when I expect content mastery, and is this going to summarize their level of content mastery, or is this something I'm going to use with the purpose of helping them to build towards more content mastery? Okay, so again, I went through some research, just did a quick glance through research out there of designing the summative assessments and came up with this document that you can download from my website here. So again, what standard are we trying to assess for mastery? Because if we're talking a summative assessment, then we're definitely talking about the standards. We're not talking about effort now, which would be more formative. We're not talking about the other things. We're talking about the standards. And does the assessment allow the student to demonstrate conceptual understanding? So just as an example, one of the 8th grade standards that we have is know that the square root of 2 is irrational. So I could just have, a question that's just a straight memorization thing that's in the standards. A question would just be, is the square root of 2 rational or irrational? It really can just be that simple. We're not talking about eliminating every form of assessment that we already know, but we are talking about what's going to get at the standard. All right, so maybe I would say not just is it rational or irrational, but to follow up for conceptual understanding, I would say why. How do you know? Can you explain why this would happen? And so then students ought to be able to connect that with a definition that a rational number can be written as a ratio, or an alternate equivalent definition would be that it has a repeating decimal pattern. Okay, and so the square root of 2 does not have a repeating decimal pattern, and so therefore it will be irrational. Okay, and most students at the 8th grade level will just know that any square root will be irrational. So that's going to be a conceptual understanding level question. You might go, so that was the giving definitions here. Another thing you might do, oh look at that, wants me to buy some more McAfee. Another thing we might do is find some errors in procedures or reasoning. So you might have a student make a case for one side or the other as to whether the square root of 2 is irrational, and then they have to explain why that reasoning is correct or incorrect. Your students would have to explain that. Classifications, justifications, writing equations, these are all kind of the conceptual understanding. Okay, does it allow students to demonstrate procedural fluency when needed? Students should demonstrate speed and accuracy. Okay, now we're not talking that they have to be, mega speedsters at math, but we are saying it does have to be fluent. Procedural fluency. This needs to be something where they don't have to second guess themselves. That it has become, instead of second guessing, it's become second nature to them, so that they ought to just be able to flow through this procedure. Okay. And it might be something where, like, if we're talking about quadratics, x squared minus 9 equals 0, students may solve that by factoring, but they also might solve by adding 9 to both sides and then taking the square root. So there are multiple ways to do this where they can show the procedure through any way that they understand. Okay. Does it allow students to apply the concepts in a rich context? Now, this is kind of one of the lies that we tell, that all of this math has such rich context that the students are going to get involved in. Well, I hope we all know that that's just simply not true. And so, really, what we're talking about application is we're not necessarily saying application to the real world, but we're also saying application to other mathematical situations. So can they apply math to other math? That would be an application level, and that would be a rich context in which to put these things, is to have students apply math to math. Okay, so it might be factoring. It might be, would be a good example, I guess, of applying math to a new math situation, where if you've talked about factoring with quadratics, then we apply that to cubics, and that is an application level, even though most of our students are never going to actually use polynomials in real life. We can still demonstrate some application for this. Okay. Does the assessment assess all the concepts and skills? So if we're going to summarize it, we want to make sure we're hitting everything. This is part of that reliability piece. So hopefully we can say, okay, here's the spread of the content, and let's look at all of it and get a good summary that's there. It suggested that we would have 10 summative assessment items for each skill that we're assessing, but a minimum of 5. So the way that I get this one done in my classroom is I have quizzes and tests and a semester exam and a project and problem solvings all over the same skills. So that way I've got those 5 different summative assessments, and they're spaced out over time to give some reliability that are all covering the same skills. And that's been useful for me and has worked really well. Can the assessment be completed within the given time frame? In other words, don't build a test that you can't get done within the class period. And does the assessment type best assess mastery of content? So, for example, a knowledge level target, do you know this? Well, multiple choice or fill in the blank or matching might be appropriate. You might be able to convince me of that for just a simple knowledge level target. But for a conceptual understanding question, we're probably going to need some sort of extended response, some sort of writing. And for procedural questions, we're probably going to need short response. We're going to, in other words, students need to be able to show their work, and maybe even explain that the procedure in a sentence or two. Okay, but if you're trying to get at a concept, do students understand a concept? Multiple choice is never going to show that. Okay, fill in the blank given a word bank, or matching given a word bank. None of these things actually demonstrate conceptual understanding. So make sure we're looking at what type of assessment have we built, or what format of the assessment have we built, so that we can actually summarize their learning well. Again, do we have a balance of the levels, whether it's CPA, whether it's Bloom's, whether it's Webb's depth of knowledge that you're looking at? Just make sure that we're including those different levels, because again, that's going to be able to differentiate between the students who are at the different levels. We're going to find out the degree of content mastery, and that gets to, can we show exceptional levels of mastery? So do we have something in there, and that ties into this levels, so that we can see the difference between the A and the B students? Can we see the difference between the meets and exceeds students? One thing that we've got going on right now is a huge amount of grade inflation, to the point where everybody is supposedly above average, and we know that's just not true. So what is it that's going to differentiate between these students? Okay. Some summative examples and what that might look like, because I get a lot of people who ask, how many points should this question be worth, and how many points should that question be worth? Make sure you check out my talk on assessments in general and best practices in general, because I've got a lot of answers to that in those videos that will hopefully be posted soon. But for right now, let me walk you through one, and we could talk about how we might assign some point values, or something like that. For me personally, I make every single test out of 100 points, because the kids understand, for the most part, 100% and a grade scale through 100, 0 to 100. So that's what I do. But here's a function test of what I might do back to the rate of change, the initial value. First of all, we've got a situation here where I give them an equation. Can they identify the rate of change, identify the initial value, identify the independent and dependent variables, so that we know what's the input and the output, because we've talked about that previously with functions and how those tie in. The equation of the function, obviously they've already been given the equation of the function, so that's I'm probably not going to assess that in this one, but I've got other modalities, like here's a graph one in which we'd need to do that. And then a conceptual description of that rate of change and initial value would go in these boxes. All right, so if we gave 3 points for each of these, 1, 2, 3, 4, 5, there's 15 points. Here's 20, and there's 25. So you get 4 of these questions together, and there's a summative example. And this would cover pretty much all of 8.f.4. Okay, and we've got 4 questions on this, so this kind of gives us 4 of those touch points that we want, and we want 10 of them. So this would not be the only summative that I would give, but this would be one of them. So this might be a quiz, this might be a short test, something of that nature, so that we're getting some of those pieces along the way that we're going to need 10. So we've got the graph, we've got the equation, we've got the table version, and we've got a modality of just words, written out situation where they have to plug in everything else. Okay, so that might be how I would do it. Coming down to our 4th grade example, here's a number, kind of a number sense one, where we're just multiplying. Okay, so can we multiply? first of all. So here's, my standard kind of multiplication algorithm right here that the student would hopefully show. And then, can you represent this with an area model? Now, I want one thing to keep clear. Common Core is not claiming that this area model right here or any other model is the best way to solve a multiplication problem. What they're trying to get at is, can the student demonstrate that they understand what multiplication means? So that, can they represent it in a different way? Because if we can represent it in a different way, then we really understand it. The biggest problem my 8th graders have, we just had a problem where all they needed to do was multiply by 4. Literally, that was it. Just multiply by 4. But they didn't know that they had to multiply by 4. And so therefore, is around 80 to 85% of my students got the problem wrong because they did not know to multiply by 4. And moreover, it was that there were 4 sides on a square. And they didn't see the connection between putting a fence around a square that you needed 4 sides. So because they didn't know really what multiplication represents, instead they just memorized the procedure, then they missed that problem. So by asking these sort of questions of, okay, can we represent this in another way, on a summative assessment, we really are summarizing their level of learning, because if a student gets the part correct over here on the left, we know they've got the procedure down, but if they get the part correct here over on the right, that's where we differentiate and say, okay, that kid actually understands it and gets the concept. I would never multiply numbers, like this. This is just, why would we do that? But it does demonstrate understanding. Okay, and then they write out in words, what steps they use to solve that. And so there's an example of that. And I mentioned that maybe what I would do is 10 points for the procedure, 10 points for the area model, and maybe 5 points for writing out the written procedure. And again, so here's one question, and you could have 4 of those questions be kind of a mini quiz, and adds up to 100 points. So here it is with 2-digit times 2-digit, the same sort of thing, and you can go that route. All right, so a summative assessment is going to be summarizing learning. I'm not necessarily going to be using the observational checklist necessarily, because it may be a little bit more formal when I'm making a test or a quiz. But there would be, I want to stress, there would be nothing wrong with having an observational checklist being a summative. That if you got to a point where a student was working on something and you could walk around and observe that they really truly understood something, and you were ready as far as time frame to demonstrate that this was a summary of their individual content mastery, then you could absolutely use any of those other formative assessment tools for the purpose, as long as we knew that the purpose ahead of time was to be summative. And so that would limit some things. That would mean that we're not going to be doing any group work, that they're not going to be working together, because that's not necessarily telling me what that individual student has mastered. But if you had a problem that they could work on, and that you could go and talk to them one-on-one a little bit while you're walking around with some of that observational checklist, that would absolutely be another one of those 10 touch points that you want to get on each individual skill or concept. So, all right, so this has been designing formative and summative assessments, and as always, if you have any questions, you can shoot me an email, and that's at ericbright2002 at yahoo.com. Thanks for tuning in.